So I was showing you. I want to share this. And, okay, I, I I show you this is talk about the memory layout and where you do the when you do the dereferencing a null pointer, that this memory layout basically give you the segmentation fault. But I want to go a little bit further to give you some idea to understand three different memory regions. That the first region is called stack, the second region is called heap, the third region is called initialized data, or just the data area. And the thing is that C programmers, sometimes you need to know this picture in your mind, so you know when to use new and when to use just use local variable, and when to use a static variable, because that's kind of things that you need to know, because the data will either be gone after you get out of the function, for example. Let me actually say a little bit. I will probably talk about standard template library. So in standard template library, there are two array type of thing. One is called array, one is called vector. And one major difference, so you saw I always use vector. I didn't use array. I mean, number one, vector is really fast. But the other reason is that vector is actually come out of the heap. So if you do use vector, all your stuff is on the heap, which means that it will stay there for a while. But on the user stack, it's gone after it's done. So that's why array is actually on the user stack. So you have to be careful. If you want to use array, you know the data will be gone after you exit that particular scope. Okay, so this is related to the scoping, because I saw some of you actually had a problem. Is not because you dereference a pointer, it's because you allocate that memory space on the stack. So when you exit the scope, the memory stack is gone. The memory is actually different. And then you try to dereference whatever there, and that has been reset to null or something like that. Then you got a segmentation fault bus error as well. That's the second common cause for segmentation fault. So let me explain to you what's the stack, what's a heap first. Okay, so this is typically, you can see that, okay, this picture, I copy it from one of the Google resource, and this is upside down. So they put a heap on the top and the stack on the here. But it's really in the memory space, the heap is from the lower address to a higher address. The stack is really from the higher address to the lower address. And they're approaching this way means that in the virtual address space, that they're basically pushing two directions, heap growing this way and stack growing this way. So there is some middle memory used there. So earlier, I think Chi asked, well, you got alloc arrow. Why you get alloc arrow is because you try to allocate something growing this direction on the heap. It grows so much is actually touching this line. When it touches this line, that means you're already used up your memory. Then you got, that's one situation you will get the alloc underscore bad. That's because, oh, bad underscore alloc or whatever. It's because these two are actually collide each other. And of course, that's bad. You used up your memory. Okay. But I want to tell you one is this is a one element in the call stack or the stack. See what you have on the call stack. The call stack you have is you store your local variable. Local variable means that anything you define that's actually within the pair of curly bracket, that's called local variable. Okay, and for example, you define integer x, or you define a comment x. And those are the object allocate. It's not pointer, it's just the object. It's all allocate in the local variable. And also the argument. When you call the function, the argument is there. And also there's something called return address, but you don't need to worry about from the programmer perspective is the top two is most important. So this is called call stack. It's one call stack. But when you actually make a call, it looks like this, is that because this is from the top to the bottom. So if this one is the like a main function, you try to call a function called bar. So main stack is here, elements here, and the bar is here. So you kind of grow this way. So as you call, you actually put your local variable and the function argument on top of each other, and then you have this one, this one. Let me actually show you this. This is probably a better way to say that. So here is your main function, and here's your bar. So it looks like this. So now I'm going to show you this picture, because this picture tells you that when you run the function, this is the way. So when you start to execute the function, it's actually execute the main. So you have a stack frame for main, which is contained like argc, argv. That's actually on the main. But when actually main call another function called foo, then I'm actually put another stack over here. And the foo actually called bar, okay, you have here. So you see that your function looks like this. And then you actually return from bar, now you have main and foo. See, now, right now, the bar, whatever the local variable and the argument about the bar is gone. It's basically come back. And then you foo also exit. So now you only have main here. But now when you call bar at this time, you actually add another one. But this one actually override whatever this one is. So what I'm saying is that after you exit the function scope, and your memory is not guaranteed. It might be somewhere on the memory, on the stack, but it's actually being overwritten by another function. And that's why if you have something on the stack, just make sure you know that the local variable and the argument, whatever you have, is only guaranteed during the scope of that function call, or even that pair of curly bracket. But once you get out of that, that memory could be reused and doing something else. And therefore, if you actually try to access still the same value outside of that, it's going to be unguaranteed. On the other hand, if you're using malloc and free, you're actually putting your memory on the heap, which is a different part of your memory. It's not on stack. The stack is like a main, my post.dumpj, comment.dumpj. This is actually the calling stack, local variable. But when you actually create using like a vector, using new, you're going to put your stuff in a heap. So even though you exit your function, this part will not be touched. Okay, and that's very important for you to know, that especially for C programmer, that or C++, of course. When I say C programmer, I really mean C and C++ programmer, that you should know when you should use new and alloc in order to preserve preserve your data. But if you know that this is really used local and it's gone, that's okay. Then you just use local variable. That will be fine. Okay. So that's my, let me see, that's my quick introduction to tell you a little bit about memory layout, and also why you will, you receive error that you're getting this past few days. Okay. Any question? So, okay. I'm going to stop recording.